scientific method. As I mentioned in my introduction video, this might be somewhat of a review for those of you who are familiar with the scientific method already, but it is a good refresher of overviewing the steps involved in scientific studies and how we go about conducting those studies in an appropriate and an ethical manner. The scientific method really is important for this course, even though you might not think so. But the reason for that is because all of the findings presented in the textbook, all of the findings presented in the course modules are based on scientific studies that have been conducted, and these studies help us to formulate our knowledge about behavior in the workplace. So it's really going to be helpful that you understand how studies are conducted, and then we're going to carry that information forward throughout the semester. So there are 4 broad steps that we're going to review in the scientific method for this class. Now, traditional scientific method does have more specified steps, but we're going to give you sort of the Cliff Notes version today. So for this class, you really only need to be concerned with the 4 main steps presented here. The first step in the scientific method is called theory. So anytime someone wants to start a scientific inquiry, they're going to look at existing theory to help them do so. So essentially, theory is a collection of assertions or a collection of truths or assumptions that we take to be truth, and these assertions really tell us important things about different variables. For example, theory tells us how variables are related to one another. So does one variable lead to another increasing? Does it decrease another variable? How are these 2 variables, in fact, how do they coincide? A good theory will also tell us why variables are related to one another. So a good theory helps to explain why one variable might relate to another variable. What are the underlying processes or mechanisms that are taking place that allow one variable to increase or decrease another variable? And then the last thing that a good theory will tell us is when variables are related to one another. So are there certain conditions or situations or contexts in which one variable might be related to another variable more strongly or more weakly? So anytime you want to start a scientific study or a research study, you first dig into the theory and say, what is the existing knowledge and what can I take or assume to be true based on this existing knowledge? The second step then are creating hypotheses. So after we have a theory, we can use that to then create some predictions about what we think might occur in our own study. So formally defined, hypotheses are written predictions about the relationship between variables. Now, it's very important when we are creating hypotheses that these are done before we collect any data. This is called conducting these a priori. It is not considered appropriate or ethical to collect data and then go back and try to create hypotheses. In fact, that doesn't really help us in determining whether or not our hypothesis has support. So to do things in the appropriate and accurate scientific way, you would specify a hypothesis and then you would collect data in order to determine whether or not those data support what you think is going to happen. So the third step in the scientific method is called data. And what this really refers to is the idea of collecting data and then doing statistical analyses to figure out if our data in fact support our hypotheses. So again, we're going to test those data by doing statistical analysis. More specifically, we rely very heavily on what we call correlations to figure out whether or not variables are related, whether or not our hypotheses might be supported. As a quick side note, please note in this course, a correlation, you need to know conceptually what a correlation is. You'll need to be able to interpret the correlation, but we're not actually going to be running any analyses. This is not a quantitative class. This is a content class. So I want you to understand the ideas broadly. You're not going to have to calculate anything to do well in this class. But again, you will need to know what a correlation is and be able to explain it. So we're going to go into more detail on a correlation in the following pages, or the following slides of this presentation. So a correlation is a numerical value, and it tells us about the strength of the relationship between two variables. So based on that numerical value, we can infer whether or not a relationship is weak, whether or not a relationship is strong, or if perhaps there is no relationship at all. So a correlation ranges from -1 to 1. It can fall anywhere within that continuum. You cannot have a correlation, however, of say 5 or 10. That's just not statistically possible. So anytime you're interpreting a correlation, again, it has to fall within this range of -1 to +1. So correlations can be either negative or positive. So when we say that two things are negatively correlated, what we're really saying is that the variables move opposite one another. So as one variable increases, then another variable decreases. Or on the flip side, if one variable is decreasing, then the other variable is increasing. So essentially they're showing opposite patterns. And I'm going to give you an example of this on the next slide. On the other hand, a positive correlation tells us that the variables are moving in tandem, or they're moving in the same direction. So both variables are decreasing together, or both variables are increasing together. So in this case, it's really important to note that negative doesn't mean bad and positive doesn't mean good, even though we usually use those words in that context, but instead to know that negative means the two variables are moving in opposite directions, while a positive correlation means that they're moving or mirroring one another. They're moving in the same way. So take, for example, this idea of sleep and test performance. This has been studied quite heavily in education research. It's been studied quite heavily in organizational research. How does sleep affect test performance? So what we know from the research is, generally speaking, as sleep increases, our performance increases. And as sleep decreases, our performance decreases. So really here what we see is sleep and performance moving in the same direction. They're either both going up, right, or they're both going down. Because of this, because they're moving in tandem, because they're moving in the same direction, we would call these positively correlated, right? One variable goes up, that would be sleep, and performance goes up. Or one variable goes down, so as sleep goes down, our performance also goes down. So those would be considered positively correlated. A second example is exercise and stress, another research area that's been pretty heavily studied in the literature. So we know from these research studies that as our exercise increases, stress tends to decrease. So the more we exercise, the less stress we feel. On the other hand, as our exercise decreases, our stress increases. So the less we exercise, the more stress that we feel. These two variables are considered negatively correlated because they're moving in opposite directions. So exercise is increasing while stress is decreasing. They're moving in different directions, and that is considered a negative correlation. So once we figure out how variables are moving, are they positive or are they negative, we can then figure out how strong that relationship is. And we do this by looking at what we call the correlation coefficient. So we can represent this data on a scatter plot, and the strength of the relationship is then inferred from the compactness of the data. So depending on how tightly compact the data are on that scatter plot tells us how strong the relationship might be. So a correlation of -10 or +10 is considered weak. A relationship of 0.30 or higher is considered moderate. And a correlation of 0.50 or higher is considered high. So it's important to note that in order to be considered moderate, it has to be 0.30 or higher. So a correlation of 0.2 or 0.25 or 0.27, those would still technically be considered weak. So this is the minimum cutoff. Same for a correlation. In order to be considered a high correlation, needs to be 0.5 or higher. So a correlation of 0.37, of 0.42, right, that falls in the in-between. That would be considered moderate as well. So this gives you an example. This graphic is taken, I believe, from the textbook, and this gives us a representation of what a scatter plot might look like. So here we have what we would consider a perfect negative correlation. So this would be a -1 correlation. So you can see as one variable goes up on this y-axis, or on the x-axis, then these variables on the y-axis are decreasing. Here you can see that there's still a trend. We can make out that they are in this sort of negative pattern, but they're not as tightly compact as they were over here in the perfect negative correlation condition. With number 3, you see that the dots on the scatter plot seem to just be posted willy-nilly, and there is no pattern. You can't discern any kind of line. That would tell us, hey, there is no relationship between these two variables. And then 4 and 5, again, represent medium correlations and perfect correlations, but these are positive. So these lines, again, we can see a pattern, but the pattern shows us, hey, as the x-axis increases, the y-axis is also increasing. So we see this relationship is a positive relationship. So I want you to consider this example. I'm going to give you a minute to kind of think on it. So I'll give you an estimate. So I want you to determine what the correlation is between per capita cheese consumption, so how much cheese is consumed per capita in pounds, and how is that perhaps correlated with deaths due to tangled bed sheets. So I want you to take a minute and write down, even on a piece of paper next to you, what your best guess is of a correlation between these two things. Remember, that value can be anywhere from -1 to +1. Okay, do you have your guess? Did you write it down? So it turns out that the correlation between these two variables is actually 0.95, almost 1. This is a very strong correlation between these two variables. So you might be asking yourself, how are these two things related? How does eating more cheese perhaps relate to dying by being tangled in bed sheets? Well, if you're scratching your head, if you think this doesn't really make sense, you're onto something. You're a smart cookie, because this underscores a really important point when we're talking about correlations. Before I get to that, here's just a sample of what that data might look like. So you can see that here's the plot. They're moving together in tandem, so this is a positive correlation. As cheese consumption goes up, bed sheet tangling also goes up. And so you can see, hey, those two things are really highly correlated. Fun fact, there's a website down here, tylervigen.com. You can actually go to this website and look at how other variables might be correlated with one another. This is based on real data that was collected from the United States. So what this really underscores for us is that correlation does not equal causation. So just because two variables are correlated does not mean that one variable causes the other. So in the case of our cheese consumption, it is not the case that the more you eat, the more likely you are to become tangled in your bed sheets and die. There is no relationship. This is what we would call a spurious correlation. Yes, they seem to be moving in the same direction, but actually there's no real underlying reason. It's just sort of the natural order of things, but eating cheese does not lead to death via tangled bed sheets. So we see a correlation, but it's kind of nonsense, right? There's no meaning behind it. And that's why just seeing that two variables are related is not enough to assume that one variable actually causes the other variable. So if we actually want to be able to say that one variable causes another variable, there are 3 very specific conditions that must be met. So I will give you an example as we go through. Let's assume that we want to prove that smoking causes cancer. Okay, we want to be able to use that word causing. There are 3 conditions that have to be met. So the first condition is that the two variables must be correlated. Okay, So what that means is that if we want to say that there's a causal relationship, the two variables must be correlated. But just being correlated in itself doesn't mean that causation exists. In order for causation to exist, we have to have these other two factors also present. So first, the two variables have to be correlated. That's important. The second factor is that the presumed cause must precede the presumed effect in time. So that's a very fancy way of saying that the variable we think is doing the causing must come first, and the variable that we think is being caused must come second. So in our smoking example, we must have had an individual who smoked first, and then later in time, that individual developed cancer. We can't simply look at people who have cancer now and then try to go back and figure out if they smoked or if they're smoking in the future, right? So the thing that we think is doing the causing must come first. So we must be looking at people who smoked and then later looking to see whether or not cancer developed. The third criteria that's needed to prove causation is that there can't be any alternative explanations that would exist for the correlation. So what that means is that we try to rule out other explanations. So for example, in our smoking example, we can't do just one study and declare, okay, smoking causes cancer. We might need to do some alternative studies. So in fact, maybe we would look at those people who had developed cancer and say, well, maybe it wasn't the smoking. Maybe it was that they drove a blue car. Maybe it was the fact that they ate meat. Maybe it was the fact that they worked in certain industries. So we would try to go and test alternative explanations to figure out, are there any other variables, are there any other factors that are potentially explaining this relationship? And if we can rule out all those other explanations and say, nope, those are not the reason, then we can conclude, okay, smoking must cause cancer because smoking is correlated with cancer, smoking came first and then cancer followed, and we've ruled out all alternative possible reasons for why that correlation exists. So if you want to use the word cause, right, that's a very specific word, these three things must all be present. Okay, so far we're still in that third step of the scientific method, which is the data step. So we're talking about statistical analysis. We just covered correlation. Now we're going to cover one more concept that falls under statistical analysis, and this is called moderation. Now, I'm introducing moderation to you right now. You'll notice this term is not in the textbook in Chapter 1, but rather this term moderation shows up in the textbook during Chapter 4. So it kind of comes out of nowhere, and I think it's easier to just explain it up front right now, and then when Chapter 4 comes, we can review it, but you'll already really know what it means, so you'll be ahead of the game. So when we talk about moderation from a statistical perspective, what we're really saying is it's an it depends variable. So this variable is going to tell us when two other variables might be related. So with moderation, again, it explains when or under what conditions or under what situation or circumstance a statistical relationship occurs. Essentially, if we have a moderating variable, the relationship between two other variables is going to get stronger or weaker depending on that moderating variable. So that relationship will either get stronger or weaker depending on the moderating variable. I'm going to give you an example, actually two examples on the next slides to help sort of make this idea a little bit more concrete. So, for example, I want you to ask yourself, does having an audience improve performance? So if somebody is performing, does doing that in front of other people improve their performance? So I'll give you a minute to think about that. Maybe even, again, write down on a piece of paper yes or no, and why you might think that's the case. Okay, so I told you on the previous slide that a moderation variable is an it depends variable. So when asking this question, does having an audience improve performance? The answer is really, it depends, right? For some individuals or for some situations, we might see an audience improve performance. But in other situations, we might see an audience decreasing performance. So it's going to depend perhaps on the difficulty of the task. Right? If a task is very easy, having an audience could certainly improve performance. Perhaps experience. If somebody is brand new at performing a task, doing so in front of an audience might actually reduce their performance. And perhaps there's some personality characteristics at play. So depending on how extroverted or introverted an individual is, might determine whether or not that audience helps them. So if somebody is very outgoing, the audience might improve their performance. But if somebody is very introverted, very shy, then the audience might actually hurt their performance. So this is a good example of moderation, because whether or not having an audience improves performance, it's going to depend on a third variable, again, which could be how difficult the task is, the experience the person has, or their personality. So, for example, we might say for easy tasks, having an audience improves performance. Whereas for difficult tasks, having an audience decreases performance. So here you can see that the relationship between the audience and performance changes depending on whether or not the task is easy or hard. Okay, a second example of moderation. So here's another question I want you to ask yourself. Does work stress predict drinking after work? What do you think? Again, take a minute, make a prediction on your piece of paper. Do you think work stress predicts drinking after work? All right, if you've been paying attention, you might see a pattern here. Does work stress predict drinking after work? Well, it's going to depend, right? There are certainly going to be factors that will lead some individuals to drink after work, but perhaps prevent other individuals from drinking after work. So this relationship between work stress and drinking is going to depend. Perhaps it depends on how much social support you have or your income, right? Drinking is expensive, so if you have the income to purchase alcohol, maybe we see that relationship increase. Perhaps your relationship status, and if you are in a committed relationship, perhaps if you're a parent or not a parent, right, that might have some effect, or your age. Maybe when individuals are younger, we see more of a relationship between stress and drinking, and as individuals age, perhaps they grow out of that desire. So again, this relationship between work stress and drinking, it depends, right, on some factors. So for individuals without social support, those individuals that don't have a friend system or don't have anyone they can call and vent to, maybe work stress is more likely to predict drinking for them. However, for individuals that have social support, that are able to call a friend or have a significant other that's supportive of them, then work stress is less likely to predict drinking, perhaps because they have other ways that they can vent or find catharsis for that work stress. So here, the main takeaway is that a moderating variable tells us when a relationship is weak or when a relationship is strong, and it helps to explain some of that situational or contextual factors. This is really an important concept for you going forward in this class, because starting with chapter 4 and throughout the rest of the class, we are going to be talking about moderating factors. There are lots of them presented in the textbook, mostly because you will learn that in this class, things are not black and white. There's never really just one answer, which for some students might feel a little frustrating, because often what happens in the workplace depends on a lot of other factors. So we have to be able to take situational characteristics or personality characteristics or leadership characteristics. We have to be able to take that into account when trying to make predictions about two variables and trying to create perhaps work policies or interventions. So Understanding moderation is really a critical concept. So if you have any questions at all, please reach out to me. This is certainly something that you will need to know carried forward throughout the semester. Okay, so now we're in the very last step of the scientific method, and this is the verification step. So with verification, basically what we're doing is just replicating our findings. So we're going to replicate our findings across different samples, contexts, and methods. And the reason for this is just collecting one study might give us some insight, but we can't necessarily confirm that that's a universal rule or a universal truth. We need to make sure that those findings hold in other contexts. So here we might collect samples of college students, but also samples of working professionals. Maybe we collect samples from people in leadership positions or hourly positions. So we collect different samples of individuals and see, do these relationships hold in those different samples of individuals. We also can collect across different contexts. So do these results hold in the United States? Might they hold in Europe? What about in Asian cultures? What about in Latin American cultures, right? So we want to be able to test in different contexts. Context could also include job context. So can we test in hospitality staff? Can we test in healthcare workers? Can we test with college professors, right? What context do these relationships hold true? And then lastly, we might use different methods. So perhaps we survey employees, perhaps we conduct interviews, we might set up some kind of scientific experiment, but all of these different methods help us to get at that underlying truth and to verify whether or not our results hold in these different, using these different methods of inquiry. And then the last step of verification comes after we have conducted many replication studies. After two variables have been investigated multiple times, we can conduct what we call a meta-analysis. So a meta-analysis is basically the average correlation across studies. So let's say that you are looking at the relationship of job satisfaction and job performance, and there are 50 studies that have been conducted. You would look at the correlation between job satisfaction and job performance across all 50 studies. And so you might have, in one study the correlation is 0.3, and in another it's 0.5, and in another it was 0.27, and in one it was 0.12. So we'd find all of those correlations and we would take the average of them. So just as a reminder, average, you add them all up and then you divide by the number, the total number. Whatever that average correlation is, that tells us on average what the strength of the relationship is between two variables. And as kind of a spoiler alert, meta-analyses in our field tell us that on average, job satisfaction and job performance are correlated at about 0.30. So on average, this is what that relationship looks like. So the meta-analysis helps us to take lots of different studies and sort of smush them together and tell us, okay, here's what we know, give us one correlation out of all of these studies together. So that meta-analysis is the last step in really helping us to find the true relationship between two variables. Okay, so that gets us to the end of the scientific method. Now you can move on to completing your quiz for this week. You can also move on to completing your first written assignment. If you have any questions about your learning activities, any questions about the content presented in this video, please don't hesitate to contact me. If you have a question, other people have questions, and this online format of learning is really going to be dependent on open communication between you and me, and I am here to help you, and I want to help you. So I'll be looking out for emails or for office hours, and I hope you guys enjoyed this presentation. Have a wonderful rest of your week, and we will be in touch. Take care. Bye.